Alrighty. 9.4, the tangent ratio. This is trigonometric ratios. We're going to start with a tangent. There's 3 of them. We're going to start with the tangent. So first of all, trigonometric ratios, trigonometric ratios. They're good to use in a right triangle. If it's not a right triangle, then we cannot use this. It has to be a right triangle. Okay. Before I get into that, let me spend 2 minutes or so on mnemonic devices. So a mnemonic device, yes, there's actually an M right there. It's actually the letter M. Mnemonic device. It's an acronym or a rhyme or phrase. It's something used in your memory that you do know to help you memorize something that you don't know. Okay. Let me give you some examples. So an example. Sean got us 3 A's. This is used in geography for the number of continents. Sean got us 3 A's, so capital letters. South America, E would be Europe, A would be Asia, N would be North America, and then 3 A's, Australia, Africa, and Antarctica. Another way for that would be, I like this one better. For the continents, NASA equals 4 A's. I like this better because there's actually 4 A's there. NA would be North America. SA would be South America. E is going to be Europe. And the 4 A's would be Asia, Africa, Australia, and Antarctica. NASA equals 4 A's. That's the mnemonic device for remembering the continents. Okay. Next we have, let's go with, homes. Here we go, homes. H-O-M-E-S. It's not homeboy. It's not Patrick Mahomes. No, it's just homes for the Great Lakes. H would be for the Great Lake of Huron. O is for the Great Lake of Ontario, Michigan, Erie, and Superior. For the Great Lakes. Homes. It's an acronym. Homes. Okay, this would be here a phrase. Okay. What about PEMDAS? You know PEMDAS. You've heard of PEMDAS before. Some people know it as GEMDAS, but I taught it as PEMDAS. Please excuse my dear Aunt Sylvia, PEMDAS. Please excuse my dear Aunt Sylvia. Parentheses, exponents, multiplication, division, addition, subtraction. And for me, addition, subtraction together. Multiplication, division together. Okay. Another one for biology, for classification of taxonomy in a classification system for biology. Dear King Philip came over for good soup. Dear King Philip came over for good soup. The D represents the domain. Then you have the kingdom. Then you have phylum, class, O for order, F for family, G for genus. Genus, not genius. Genus, just genius. No letter I. S for species. Dear King Philip came over for a good soup. Okay. Another one, Roy G. Biv. Some of you know this one. This is for colors of a rainbow. Colors of the rainbow. Roy G. Biv. The colors R for red, O for orange, yellow, green, B for blue, I for indigo, V for violet. Roy G. Biv. Okay. So those are examples of mnemonic devices. Okay. Mnemonic devices. So I'm going to show you something for trigonometric ratios. It's SOHCAHTOA, but basically SOHCAHTOA. This mnemonic device, SOHCAHTOA, that device right there, or acronym, SOHCAHTOA. You can also, well, let me explain what this is for trigonometric ratio first. Okay, S is sine. Sine is well, I'll tell you what this stuff is. S is for sine. O is the opposite side of the triangle. Right triangle, has to be right triangle. H is the hypotenuse. C represents cosine. A is adjacent side. H is hypotenuse. Adjacent divided by hypotenuse. T is tangent. O is opposite side, and A is adjacent side. So if you write in your URL on your phone or computer, if you typed in some old hippie, I'm going to leave it there, and you can get a whole bunch of different acronyms. Sorry, that is the acronym. You're going to get a whole bunch of different phrases to help memorize SOHCAHTOA. Okay, some old hippie, and then it's going to come back with a whole bunch of more stuff. But I've seen a bunch of different uses of this acronym, SOHCAHTOA. Okay, so for a right triangle, it has to be a right triangle. If it's not a right triangle, then you cannot use these. It's only for a right triangle. Okay, so in this case, if I'm saying the letter R, first you have to find out which angle you're referring to. So if I'm talking about the letter R, if I want to find the sine of R, sine is going to be defined as the opposite side divided by the hypotenuse. Here's R, the side opposite. Well, I'm going to do hypotenuse first. The side opposite the 90 degrees is always going to be the hypotenuse. The side opposite the 90 degrees is the hypotenuse. It's always the longest side. This has to be the longest side in a right triangle. So that's the longest side. The side right next to this, the adjacent side, is 4. And that just leaves us with the side opposite R. That's the opposite side. So sine of R would be opposite side, 3, divided by the hypotenuse, 5. Sine of R would be 3 divided by 5. If you said sine of P, well, P is right here. The hypotenuse is 5. Relative to P, this is adjacent to P. Adjacent meaning next to. This would be adjacent. Relative to P, that's the opposite side. So sine of P would be opposite side 4 divided by hypotenuse 5. Sine of P is 4 divided by 5. Okay. Cosine of P, cosine is the adjacent side divided by hypotenuse. The adjacent side is 3. Hypotenuse is 5. So cosine of P is 3 divided by 5. If we said tangent of P. Tangent of P is the opposite side divided by the adjacent side. Tangent of P, okay, relative to P, that's the opposite side. Relative to P, that's the adjacent side. So 4 divided by 3. Okay. So in today's assignment, you'll be asked to take a right triangle. You have some sides, and you have to write it as a fraction and write it as a decimal to 4 decimal places. So 1, 2, 3, 4. There's 4 places past the decimal. So if we took tangent of R for that triangle, tangent of R, tangents divided by the opposite side divided by the adjacent side. Relative to R, that's hypotenuse. That's an opposite. That side is opposite R, and that's adjacent. So tangent is defined as the opposite side, 3, divided by the adjacent side, 4. That's a fraction, and to write it as a decimal, 0.75. Okay, in college, you would not even get credit for that. It says 4 places past the decimal, 1, 2, 3, 4. So that right there, 3/4 on a calculator. 3 divided by 4, it just says 0.75. This says go to 4 places past the decimal. Okay, now that's 4 places past the decimal. Okay, that's a fraction. That's 4 places past the decimal. Done. Now find the tangent of P. Where's P? Here's P. Tangent of P is going to be the opposite side divided by the adjacent side. Opposite is 4. Relative to angle P, the adjacent side is 3. That's as a fraction. As a decimal, 4 divided by 3 equals 1.33333. 1.33, 4 places past the decimal. 1, 2, 3, 4. Done. Okay. What about this one? This true. What? Okay. Tangent of T. Where's T? Here's T. Okay. Tangent of T. So T. Here's T. Opposite side divided by adjacent side. The opposite side is 8. The adjacent side is 12. We can simplify that. 4 goes into there twice, 4 goes into there 3 times. So simplify the fraction if you can. And then 2 divided by 3 is going to be 0.666666666 as a fraction. 4 places, 1, 2, 3, 4. It's not going to be 4 sixes because that last 6, 1, 2, 3, 4. The next one, that's 5 or greater, so we have to round that up. So this would be 4 places past the decimal. Okay, tangent of u. Here's the letter u. Side opposite that is 12. Side adjacent to that is 8. Simplify that fraction, so that would be 3 over 2. Do not write it as 1/2. 1.5. Do not write it as 1/2. These are trigonometric ratios. There are no units associated with this. There are no units. Okay, the units cancel each other out. There are no units. It's just a ratio. So leave it as 3 over 2. Do not write that as 1.5. Do not write that as 1.5. Just leave it out that. And that, written as a decimal, is 1.5. And in college, you would not get credit because it says 4 places past the decimal. Okay, 1, 2, 3, 4. There we go. Simple. Done. Bin. Now we have this one. We have to what? We have to solve for the value of x. What the heck? Well, we know tangent. By the way, tangent, it's not what girls want to see at the beach. Tangent is defined as the opposite side divided by the adjacent side. I like that joke. Hey, here's 42 degrees. Excuse me. Relative to 42 degrees, that side is the opposite side. Relative to this is the adjacent side. So tangent of that angle is going to be opposite divided by adjacent. Opposite divided by adjacent. So the length of the opposite side is x. The length of the adjacent side is 36. Now we've set it up into an equation. The rest is the algebra stuff. So we have to go from geometry to this. This is the algebra portion from here on out. So now we have an equation. We have to solve for x. X is in the numerator where we want it. So we have to get 36 to the other side. So 36 in the denominator. So basically we're taking x divided by 36. And the opposite of dividing by 36 is multiplying by 36. You do that on both sides of the equation. 36 cancel. X equals 36 times tangent of 42 degrees. Okay. Now on your calculator, here's what I always suggest when you're working with this stuff. I want to take sine of 30 degrees, and you should get 0.5, 0.5. You should get 0.5. If it's not 0.5, see this button right there? That button, DRG, degrees, radians, gradients. If it's in radians, watch what happens if I press sine of 30. It's the exact same thing that I'm doing. I press equals. I should get 0.5. I'm not. That tells me I'm not in degree mode. So on your calculator, whatever you're using, you have to make sure it's in degree mode. Well, that's not what I want. What about this? Gradients. Well, let's try that. Sine of 30. Do I get 0.5? Oh, no, close. Still not 0.5. That's not what I want. Okay, let's try degrees. That's what I want. Sine of 30. I should get 0.5. Bingo! Now I'm in the proper mode. Now I'm going to use this. So 36 times tangent of 42. So for this specific calculator, I'm going to do tangent of 42 first. Tangent of 42. I'm going to do that first, equals. Then I'm going to multiply it by 36 to get my answer. 32.4145 equals x. There are no units. Boom, 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 boom. There you go. 4 places past the decimal. 32.4145. I don't know if you can see that in the calculator. Okay, boom. Flip it over. Here we go. I might be able to bring that. Bring them down. Bring them down. All right. Right here. Here's a triangle. It's a right triangle. We can do this. What? We don't have this. Whoa. I don't have this. Well, how can we take tangent of B if we don't know the opposite? Hey, you know what? We do know it's a right triangle. We know the Pythagorean theorem. We could figure that out. We also know it's a 45, 90. That has to be, since these have to add up to 180, that has to be 45. Hey, that's a special right triangle. 45, 45, 90. That side has to be 5. There, tangent of B. Here's B. Opposite side is 5. Adjacent side is 5. Simplify that to 1. 4 places past the decimal. Done. Tangent of R. Here's R. 5 divided by 5. The answer is 1. Boom. Look at that. What about over here? Tangent of H. Tangent of H. So here's H relative to the opposites. What? It is a right triangle. So can we use Pythagorean theorem? No, Pythagorean theorem, you need, of the 3 sides, you need 2 sides. We only have 1. What? Good that we know that these 3 angles have to add up to 180. That has to be 30. Now, this is a 30, 60, 90. Boom. Use what we already know. If that hypotenuse is 12, the side opposite 30, that is going to be half of that. That's 6, and that's going to be 6 root 3. Sweet, look at that. Using what we already know. Boom. Tangent of H. Here's H. The side opposite is 6 root 3. Divided by the adjacent side is 6. Those 6's cancel, and you have just the square root of 3, or 1, which is just the square root of 3. Square root of 3. Square root of 3, 1.73, 1.7321. Boom. Tangent of K. Here's K. Opposite over adjacent. Opposite over adjacent. Opposite side is 6. Adjacent side is 6 root 3. Those 6's cancel. And you get 1, 1. You get 1 over square root of 3. And if you remember in algebra, you cannot, to simplify this, you cannot have a radical in the denominator. So how do we get rid of that? We have to do this. Now, this is outside, that's inside, so we just get square root of 3. And we just went over this, but I'm going to do it anyway. Square root of 12 times square root of 12 is 12. Square root of 17 times square root of 17 is 17. Square root of 57 times the square root of 57 is 57. Square root of 3 times square root of 3 is 3. Now, personally, this is fine here, but personally, I like to do this. This is outside a radical, that's inside a radical. For some reason, people take this and they assume it looks like this, and they go, oh, that equals 1. And no, 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 no. No, it does not. That is the square, that's inside the radical. This is not. Okay, so that would be the simplified version. So as a fraction, square root of 3 over 3. As a decimal, square root of 3, 1.73 blah, 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 divided by 3 equals 0.5774. Boom. There we go. Okay. Okay, and one last question. Where's my dog? Where'd the doggy go? The doggy. There's the doggy. Let's talk about these horizons. So here's a person, a beautiful Picasso would be proud. Oh, your art teacher would be proud. Here's a person. This is their eyeballs. This is their horizon right here. That's their horizon line, right where their eyes are. Anything below that is the angle of depression. So where the horizon is, if you go below that, that's the angle of depression. You're bummed, you go down, depressed. If you go above that, you're elevated, it's the angle of elevation. So this angle, relative to your horizon, is called the angle of elevation. The angle below the horizon is called the angle of depression. So for this person, their, oops, that pin just fell off the side of the desk. This person, their horizon is right here. Their horizon is right there. For this dog with a huge head, the dog's horizon is right here. So relative to the dog has an angle of elevation to look up at the person. Relative to the person, here's their angle, here's the horizon. They have to look down, the angle of depression, to look at the dog. Okay? I'm gonna put my thing. There's my thing. Here we go. We're gonna find, hey, if the sun's elevation, sun's angle of elevation happens to be 40 degrees. The sun's right up here. Okay. It's 40 degrees right there, and you have some building that's 10 feet high. Here's a beautiful building. Oh, what a beautiful building. Oh, it's got windows. It's got a door. Hello. Okay. How long is this shadow going to be if this building is 10 feet high and an angle of elevation is 40 degrees? How long is that shadow going to be? Well, we're going to use, that's a right triangle. That's a right triangle. We're going to use trigonometry. We have 40 degrees. Relative to 40 degrees, that's the opposite side. Opposite side. Relative to this is the adjacent side. Okay, so we're going to use SOHCAHTOA. It's tangent. Opposite divided by adjacent. So tangent of that angle, 40 degrees. 40 degrees equals opposite side divided by the adjacent side. I'll use S for shadow. Okay, there we go. Now that's an equation. The rest of this is algebraic. The geometry portion is done. Okay, right now we have S. S is in the denominator. We don't want it in the denominator. We want it in the numerator. So we have to multiply both sides by S. These S's cancel. Now it looks like this. 10 equals S times tangent of 40 degrees. S is in the numerator. Sweet! But wait a minute. S is in the, we got it in the, how do you, oh, we still need to get this junk to the other side. All this stuff, we want to get tangent of 40, all of it over. So we're going to divide both sides by tangent of 40. Those cancel. On the left side, you have the shadow. On the right side, you have 10 divided by tangent of 40 degrees. So sine of 30.5, nice, in the proper mode. 10 divided by tangent of 40 equals 11.9175. 11.9175. 11.9175. I don't know if, there we go, kind of in there. Hopefully you can see that. 9175. So the length of the shadow S equals 11.9175. And we're done. No, we're not. Units. No, we're not. Units are feet. Now we're done. Yes, we are. Boom. Good luck, guys. Hasta la bye-byes.